Let's talk about how to transform this reciprocal function y equals 1 over x. Let's say we wanted to move it right 3 units. If we wanted to move this function right 3 units, in here with the denominator down with x, I would need to do a minus 3. And you can see the graph transform to the right 3 units. That would also move the asymptote from x equals 0 to x equals 3 as well. There it was. Maybe I wanted to move it down 2 units. So then I just need to subtract 2 at the end. You can see that would move the graph down 2 units. The horizontal asymptote then would move down to y equals -2, like so. Maybe I wanted to reflect it over the x-axis. Well, I just need to put a negative out in front or a negative in the numerator with that. And you can see that the function switches from having its branches in quadrant 1 and quadrant 3. Remember, your quadrants are 1, then 2, then 3, then 4. So currently its branches are in 1 and 3. If I reflect it over the x-axis, its branches will be in quadrants 2 and 4. If I wanted to reflect it over the y-axis, I would put a negative in here in the denominator with the x, and you can see it pretty much looks like the same thing happens. So, I mean, you can envision flipping the branches over the x and y axis, and you see that they both end up in quadrants 2 and 4 instead of 1 and 3, like that. So it's just a matter of knowing where to put numbers. If I want to stretch it vertically by a factor of maybe 4, instead of a 1 in the numerator, I would have a 4 in the numerator. This point right here, normally that was 1 unit right and 1 unit up and 1 unit left and 1 unit down from the intersection of the asymptotes, is now 1 unit over and 4 units up, 1 unit over and 4 units down. So you can use that key point to help identify a stretch or compression if one has taken place. Go back to 1 over x. If I wanted to compress it, I wanted to multiply by a factor of 1/3. Multiplying by 1/3 would be the same as dividing by 3, so I could just put a 3 in the denominator, and you should see a little bit of a vertical compression there. So watch this y value specifically here. It goes from having a y coordinate of 1 to when I put the 3 in the denominator, now it's down here and it has a y coordinate of 1/3. With that. So you can see the stretches and compressions taking place. If I wanted to do a bunch of different things all at the same time, maybe I wanted to go right 2 units, so I put a -2 in the denominator. Maybe I want to go up 1 unit, so I put a +1 at the end. Maybe I wanted to have a reflection over the x-axis, so I put a negative out in front of that, and that would move the asymptote line. Since I went right 2 units, I would have an x equals 2 asymptote there, and since I went up 1 unit, I would have y equals 1 for the horizontal asymptote. Again, there's no stretch or compression here because, again, I can look at the asymptote lines and I can see from the intersection I'm over 1 and up 1 and over 1 and down 1, like that. If I wanted to put a stretch in there as well, change that to a 2. Again, now I can look at those asymptote lines and I see I'm over 1 and down 2 instead of 1. I'm over 1 and up 2 instead of 1. So I'm seeing that vertical stretch in there as well. That's kind of how you apply some transformations to this function. If you have questions, again, reach out. I'll do the best I can to explain that to you if you're struggling. But this is just kind of an extension of content that we've already covered in multiple different sections with multiple different types of functions, just showing you how to apply it to these functions and how to connect the equations of the asymptote lines to the numbers that you're seeing in the function here. With that. So again, look, the horizontal asymptote was y equals 1. You see I've had a +1 at the end of the function here. The vertical asymptote was x equals 2. This -2 inside moved right 2. So you can kind of see a connection there, the opposite of that sign for your vertical asymptote as well. So again, reach out if you have questions, and that's that.